Hi everyone, today I'm going to be going over some difficult GCSE Paper 1 questions. So grab a pen and grab a piece of paper and let's get into it. Question 1. Electricity in the UK is generated in many ways. The figure below shows an undersea turbine. The undersea turbine uses tidal energy to generate electricity. Now, I specifically chose this question because even when I used to revise for GCSE Physics, I would often overlook this topic. I think many people don't really revise for this topic. It's part of Topic 1 UK Energy Mix, or the energy topic. And so I'm just going to quickly go over what actually is tidal energy and why do we need to know it. So typically in GCSE Physics, you are expected to know that a tidal is basically like a dam, and this is built across the mouth of a river, and it uses the movement of the sea during tides to generate electricity. That's literally all you need to know. But in this picture, they've told us that we are using undersea turbines. Now we can sort of interpret what could actually be going on. So these are essentially underwater wind turbines, and we can kind of see that because they've got these sort of structures. Let me quickly draw that in a different color so it's easier for you to see. Like, they've got these structures. So we would know, like, underwater wind turbines, and maybe they work because wherever the tidal currents are strong, it uses a generator to make electricity. The first question is actually asking us, what is the original source for tidal power schemes? This is just gravity. Explain 2 advantages of using undersea tidal turbines to generate electricity rather than burning fossil fuels. So, what do we actually know about fossil fuels? Well, fossil fuels, we can just quickly annotate that fossil fuels, they release CO2, they are non-renewable, and release other pollutants. So we can say that tidal energy is renewable, therefore it won't run out like fossil fuels. This gives us 2 marks. We could also say that undersea tidal turbines don't emit CO2, so they won't contribute to global warming. We could also say that they don't produce particulates, so less effect on health. But the one I'm going to go for is that we're not emitting of sulfur. So no acid rain. Now, we should know that sulfur dioxide, commonly written as SO2, can cause acid rain and respiratory problems. That could come up as a question as well. Some power stations burn wood instead of fossil fuels to generate electricity. A coal-burning power station burns 6 million tons per year. I'll highlight that for you. Coal has an average energy value of 29.25 megajoules per kilogram. Wood chipped from willow trees has an energy value of 13. And so a hectare of agriculture land can produce 9 tons of dry willow wood per year. If this power station burned dry willow wood instead of coal, how much agriculture land would be needed? So our first step is to work out the coal consumption per year. Now, how we are going to do this is to convert 6 million tons into kilograms. So 1,000 kilograms is equal to 1 ton. Now, although this is a really uncommon unit conversion, it's really important that you still know this for your exam. So what we need to do is do 6 million multiplied by 1,000 to give us this in kilograms. And then we're going to multiply this value, which I've highlighted now in purple. We're going to multiply this value by 29.25 in order to get the coal consumption per year. And when we do this, we get 1.755 times 10 to the 11 megajoules. Now, our next step is to work out how much energy 1 hectare of willow produces per year. In order to do this now, we've got to do 9 multiplied by 13 and multiplied by 1,000 to also give us the answer in kilograms, and this gives us 117,000 megajoules per year. So in order to work out how many hectares are needed to match the energy from coal, what we're going to do is divide our first value by our second value. So when we write that in and put it in our calculator, that gives us 1.5 million hectares. And obviously make sure you write it here. Now for our next question, it gives us a table, and it says the table shows the CO2 emissions of 4 fuels used to generate electricity. Direct CO2 emissions are the amount of CO2 released when the fuel is burnt. Life cycle CO2 emissions is the total amount of CO2 released during all stages from fuel extraction to when the fuel has been used. We need to use the data from the table to explain why wood is considered to be a low CO2 emitting fuel. You should note that this question is only 2 marks, so it is actually not that brain-meltingly difficult. They have added a lot of values just to kind of confuse you, but also help you at the same time. Now, initially when we see this, we can clearly see that wood has a very, very high direct CO2 emissions in kg, but its life cycle CO2 emission is also very low. So that's literally what we need to write to achieve these 2 marks. Now, on to our next question. The figure below shows a roller coaster. The roller coaster car is raised a vertical distance of 35 meters to point A by a motor in 45 seconds. So for the roller coaster car to travel to A, it has only taken it 45 seconds. I'm just going to annotate. And it travels 35 meters. The mass of the roller coaster is 600 kilograms. The motor has a power rating of 8,000 watts. Calculate the percentage efficiency of the motor. In order to do this question, we need to work out the gravitational potential energy. Once we have worked out the gravitational potential energy, we will use this energy and substitute it in our power formula. And once we do that, we will work out the power and use the power to work out the percentage efficiency. So let's start off. To work out the actual gravitational potential energy, we need to use the formula mg multiplied by h. I've written mg delta h because I just thought of the A-level one, so my apologies for that. But what we just need to do is the mass, which is 600, multiplied by the gravitational field strength, which is 9.8, multiplied by the height 35 to give us 205,800 joules. Then our next step is to work out the power. Now the formula for power is energy out of time. We've worked out our energy over here. Now to work out the power, I'm simply going to do the energy divided by the time, which is 45 seconds, and that will give me 4,573.3 watts. Now for our final step, we need to work out the percentage efficiency. So the useful power, this value here, so I'm going to substitute it into this part of the formula, and then for the total power they've given it to us over here. So using all the data, let's work it out. We need to multiply by 100 to get it in percentage, and that gives us 57.17% or 57.2%. The roller coaster rolls from point A to point B, a drop of 35 meters. Calculate the speed of the roller coaster at point B, and we need to assume that the decrease in potential energy store is equal to the increase in the kinetic energy store. All of this for 6 marks. Now for this question, we need to work out the gravitational potential energy and the kinetic energy in order to get our speed. So we've already worked out the gravitational potential energy in part A, so we know that GPE, but because this is a new question, we need to re-show our working out. So if I just write GPE is equal to mgh, the mass is 600 multiplied by 9.8 multiplied by 35 to give us 205,800 joules. Now, according to the law of conservation of energy, in a closed system, no energy can enter or leave. The total energy is consistent. Therefore, this means that the total energy is equal to GPE, the gravitational potential energy, plus the kinetic energy. So kinetic energy and gravitational potential energy are equal. So I will now use the formula for kinetic energy, which is a half mv squared. Now let's quickly rearrange in order to get v. I'm going to help those who don't know how to do this. So what I would want to do is to remove the a half. So I'm going to multiply by 2 on this side to get 2ek. And then I'm going to divide it by m. And because we want to remove this squared on the v, I'm going to square root this answer. Now we just need to substitute our values into our formula. So 2 multiplied by our energy, all out of the mass, which is 600. And if we square root that, that will give us 26.2. Figure 1 shows a woman filling her bathroom sink with hot water. The mirror changes from being dry to being covered with small drops of water. Name the process causing this change on the mirror. Now, initially, when looking at this question, you might actually think that it is condensation. However, it tells us that the mirror is being converted into small drops of water. If they are drops, this is a solid. So, therefore, this must mean that it is conduction. For part B of the question, the woman dries herself with a towel. She hangs the wet towel in her bathroom to dry. So, the figure 2 shows 2 places where she could hang the towel. either on the unheated towel rail or the towel ring. The towel will dry faster if it is hung from the unheated towel rail instead of the towel ring. Explain why. Well, you can clearly see, well, it is a bit blurry, I'm not sure why, but the towel ring is sort of just a circle and you can just place your towel like that. Whereas the unheated towel rail is like this. Don't judge my art skills, please. Now, the towel rail has a higher surface area. Like, think about it logically. If you were to place your towel in literally just a circular ring, the towel would be more squashed up and more tightly packed. Whereas if it is on a rail, it's just more spread out and there's more area for the towel to be exposed to. So there is a larger surface area. So water can evaporate faster. Or you can also say water molecules can escape. This was a very poorly answered question because students genuinely found it more difficult. Helium is a gas that occurs naturally. There is very little helium on Earth. Helium has important uses in medicine and is also used to inflate party balloons. Some scientists believe that helium should not be used to inflate party balloons. Suggest why. This is for 2 marks. Now, questions like these are usually very poorly answered simply because everyone just thinks very scientifically and they don't really just think logically. The question tells us that there's very little helium on Earth. So we can quite literally say that helium will run out one day. Because helium will eventually run out one day, this means that it shouldn't be used to inflate party balloons. Some small fractures do not show up on an X-ray image. To see the fracture, doctors inject the patient with a radioactive isotope. The image is formed by detecting radiation as it leaves the body. The figure shows an image of a foot after the patient was injected with the radioactive isotope technetium-99. I'm not sure if I pronounced that right. But this emits gamma radiation. What is gamma radiation? Well, gamma radiation is simply electromagnetic radiation from the nucleus. So our next question is part B, which asks us why is a gamma emitter most used? Well, we should know that a gamma is the most penetrating. This means that it is able to pass through your body without causing much harm or even little to no harm, whereas alpha radiation is the least penetrating. So it will most likely go into your body and cause harm. So because it is the most penetrating, this means that a lot of the radiation will leave the body. So, because more radiation leaves the body, this allows doctors and scientists to detect what it is outside the body. So, it has a half-life of 6 hours. Give the meaning of half-life. Half-life is the time it takes for the number of nuclei of the isotope in a sample to halve. After treatment, hospital equipment may become contaminated. Describe the level of the hazard associated with contamination with technetium-99, you should include a description of how the level of hazard changes over time. Well, what we could say is that, so they've sort of given us a clue with part C because they've mentioned the fact that they're of 6 hours. This means that initially, when, this is in the body, there is a very high level of hazard. However, the level of the hazard drops to a low level very quickly due to the short half-life, and that is what will give us the next 2 marks. Some of the hospital equipment may also be irradiated during treatment. So, to quickly explain what irradiation actually is, it is simply when you are in the presence of radiation. Just because something has been irradiated does not mean it is contaminated. Contaminated is the direct touch or the direct effect of a radioactive substance. So equipment becomes irradiated when it is exposed to ionizing radiation. And why is irradiated equipment not hazardous? Because it doesn't become radioactive. And that is it for today. These are all the questions I've gone through. I hope they weren't too hard. I literally just Googled some challenging GCSE physics questions, and these are what came up first, and I just simply went through them. If there is anything you would like me to go through, please let me know in my comments. I can go over GCSE biology, chemistry, physics, religious studies, Islam and Christianity, business studies, and possibly even GCSE statistics and also GCSE maths. I wish you the best of luck with your GCSEs, and thank you for watching. Please subscribe and share a comment and like the video. Thank you. Bye.